I wasn't recording.
3, 1.
Yeah, so the x coordinate is what? 3, and the y coordinate is what?
1.
1. What do you realize with the two graphs? Compare the x coordinate and the y coordinate for these two graphs. What would you say they are? I'm looking for one word. They are the what? Start with S.
Sorry, what?
S. How would you compare this x value and this y value that where the two graphs meet? They are the SAME, same. All right. Hello. Hi.
Hello.
Yes. So I'm saying that these two graphs have the same, they have one, as you can see, they have one y value and an x value in common. Are you seeing that?
Mm-hmm.
So the two of them meet at the same x and y value. Okay?
Okay.
So we call this x and y value that the two graphs meet their simultaneous solution. Okay?
Okay.
Are you following?
Mm-hmm.
Again, where these two graphs meet, we call it their simultaneous solution. Okay? So that means that when them ask you about simultaneous equations, solve the equation simultaneously. What you're being asked for is what value of x and y the two equations or the two graphs have in common. Okay? So again, when somebody says solve the equation simultaneously, what we're saying to you is you are to find the value of x and the value of y that is the same for the two equations.
Okay.
Do you understand what I just said?
Mm-mm.
Should I repeat?
Yes, sir.
So,
So when you're asked to solve an equation simultaneously, what you're being asked to do is to find out what value of x and what value of y two equations share in common, like what I mean by that.
okay.
You understand that?
Yes,
Yeah.
sir.
Now tell me what each one understand from that while ago.
Huh?
One here want to understand.
So basically, what you're saying is that for this, what I get from it is that you want to know. In other words, you want to know where the two lines meet. So you want to know where the common factor of both of them.
The common
exactly
x
where the line meets. Like it say,
the common x
y.
and y coordinate.
Where do the lines meet, and then exactly which part they meet, right?
Right, and that will be the common x and y coordinate.
Yes, sir.
Okay. Okay. All right. If you see Kimberly disappeared, she has to go by 11 to go to work. So she will join us tomorrow for the full session, but she will go for 11. All right. So again, solving the equation simultaneously mean we're being asked where the two equations meet, that common point that they share. Okay. And in this case, we know it's a value where x is 3 and y is 1. Okay.
1.
Now we're going to look at how we can work it out. That is a graphical solution for the simultaneous equation. Now we're going to look at how we can solve this equation. Ready? Now.
Like how you have x right there, you think? Let's see if it's the same way you're working. Go ahead.
I'm teaching the concept right now because I don't think this was taught in the first set of classes that went on. So I'm actually teaching this. All right. So now I have two equations. The equation 2x plus y equals 7, right? So again, 2x plus y equals 7. And remember, what does it mean? What does it mean when we say to solve them simultaneously? What are you looking for?
Where the two lines meet.
Where the two lines meet. And I'm going to be specific. You want to find the value of x and the value of
X.
y that the two lines share in common. Say that. Why you say that?
I want to find the value of x and the value of y where the two lines share.
That the two lines share in common.
That the two lines share in common.
All right. So let's go. You have 2x plus y equals 7. All right. Now, what I'm going to do with this equation is I'm going to be writing this equation in the form of either x or y, meaning I'm going to make x or y the subject, and you will see y. Okay. Ready? So to make x, y, I'm going to make y the subject. To make y the subject, I have to remove this 2x and bring it over the opposite side, right? So I will get y equal to 7, and this is a positive 2x, right? So it's 7, 2x will go on the opposite side and become minus 2x. Okay?
Minus.
All right? Agree with that? All I did was just transpose the equation, okay?
Yeah.
So the two equations are basically the same, they just look different, all right? Now, the second equation, so this is equation number 1. The second equation we have, and I'm going to stretch across here, we have x minus 2y equal 1. And again, with these two equations, I'm going to write this equation to make y the subject. Ready? To make y the subject, I am going to reverse this positive x here, so, okay? So positive x will go over, become negative x, right? So I end up with negative 2y equal to 1 minus x. True? Now remember, the only reason why I'm changing the sign to negative here is because what we're doing to the x is a subtraction, right? What we're doing to it here was an addition, okay? So we're adding it, and so we have to go over there to do the opposite of what you're doing here. It's positive this being added, we have positive this being subtracted, okay? So the operation is taken away and addition. No, I'm not done. I don't want negative 2y. I want y. Okay? So now we have negative 2 being multiplied by y. So if I bring it, I don't want it to negative 2 beside the y. So I bring it on the opposite side and it becomes, what does it become?
Negative 2
goes on the opposite side. Negative 2 is multiplying. It goes on the opposite side and becomes division by negative 2. If you realize, I didn't change the sign from sub-negative. Why? Because what I was doing is I'm reversing negative 2 being multiplied. Multiplication is what I'm reversing. I can't reverse two operations at the same time.
Okay, so because they changed it into the multiplication, the negative remains.
The negative remains. I'm reversing multiplication.
But if I wasn't doing the multiplication, then the negative would have been positive.
If this was a 2 plus y or a 2 minus y, the 2 would have become positive 2. Not divided by positive 2, you know. It would be adding positive 2 on the opposite side. Okay?
Right.
All right? Cool? So now I have these two equations in the form of y. So y equal that and y equal that. Cool? So what we're saying now? We're saying that, remember, when we're solving the equation simultaneously, we said that it means that the two equations, equation 1 and equation 2, the two of them have one x and one y value in common. That's how you go?
Yeah.
Agreed. So if I say, if this say y, the value of y is equal to this, and the value of y is equal to this, then I could say 7 minus 2x is the same as 1 minus x divided by negative 2. Would I be wrong? Remember what it means to solve simultaneously. And look at these two statements. So remind me again, Trisha, what does it mean to solve simultaneously?
You want to see where the x and the y value, the x and y value have in common, where they meet on the graph.
Okay, kind of break up there a while ago, so I didn't get it clearly. Go again.
You hearing me? I think I'm offline.
Oh, come back online.
So solving simultaneously, you want to see where it's breaking up. I'm not hearing you.
Yeah, man, you're breaking up. You want to find out what value of x and what value of y the two equations have in common, which means this equation number 1 and equation number 2 have one y value which is the same, don't? And them have one x value which is also the same, don't?
Which is also the same, right?
And if them have the same x value, them going to have the same y value, don't? Agreed fully?
Yes, sir.
All right. So what we are saying, look on the statement here. Remember they say y for the equation are equal to 7 minus 2x, right?
Yes.
The value of y are the same as 7 minus 2x. Over here, so we rewrite this equation. We say the value of y is the same as 1 minus x over negative 2. So what we said down here now is that 7 minus 2x, which is the y value, are the same as the y value over here. So am I wrong? I am saying that y equal to y over here. So y equal y. Try wrap your head around that.
Y equal y. I don't know. Here, what we does something here. It was just yesterday. I was practicing simultaneous same something here. I know this is totally different.
Because they didn't understand what you're doing. I'm trying to make sure you understand right now. That's a problem with just practicing procedures. I want you to understand it. So me soon show you the procedure where you are do. Okay? So let's go again. This means, remember, y equal this. Just forget about what I learned yesterday. Okay? And focus on what's going on right now. We say y equal that, yeah? So what does this represent over here? So what variable does this represent? Or what value does this represent?
The seven there, that's a 7 minus 2x.
Yeah, what does
basically you're asking if this and this is the same thing, the 7 minus 2x over the 1 over x.
Are they the same thing?
It don't look the same to me.
It don't look the same, but remember that the two equations have one value of y and one value of x in common. So they have the same, they have one value of x and one value of y, which are the same, not true? Trisha? As that, right?
Yeah.
And we are saying that when you solve the equation simultaneously, the two equations have one value of x and one value of y, which
and
are
a value. Yes, sir.
So if me say 7 minus 2x, what does this represent here side of the equation? What variable does this represent?
X.
What is the 7 minus 2x? What is it the same as?
Y equals.
It's the same as y, right? Trisha, y. It's the same as y. So that this y are the same as 7 minus 2x. Are you seeing that?
Yes, sir.
So again, y is the same as 7 minus 2x. Are you seeing that? So if we put
Yes,
7 minus
sir.
2x, what does this represent down here, sir?
Why?
So basically what I say is y are the same as y. That's all?
Mm-hmm.
But this 1 minus x over negative 2 are the same as y, don't?
Yes, sir.
For the other equation, don't?
Yes, sir.
You follow that?
Yes, sir.
Okay, so what we're saying here, so Trisha, is me say y are the same as y. And we're saying that when we solve the equation simultaneously, the two equations have one value of y, that is it? Same.
Mm-hmm.
You're wrapping your head around that?
Alright. Let me see probably where I'm having that problem. You see, when you say they are the same, because is it that when the answer that you get for each of them work out to be the same, or
Exactly.
because for some reason we just look on the 7 minus?
Yeah, man, the answer, when you work out over here, so the y value over here, so going to be the same as the y value over here, so. So the two equations, them give you the same y value. And then give you the same x value. That's basically what we're equating here, so. Like what on the graph, Trisha? Yes. The two equations, them, when you plot them, then give you one similar y and one similar x value. Okay?
Okay.
You get that?
Sir.
All right. So what we're saying again, Trisha, is that if the values of y for the equations are the same, the value of x is also the same, don't? So we can solve this equation and find the value of x, don't?
Yes, sir.
So let us work the equation. If we solve this equation now, this negative 2 here, so I divide, right? Trisha? So it has to come over the other side and become what?
Yes, sir.
Yes, so when the negative 2 come on the other side,
Multiply.
it becomes multiply. So we have negative 2 is multiplying by what? 7, not true?
7.
By
Yes,
7.
sir.
And is it only the 7 it's multiplying by?
No, sir.
What else is it multiplying by?
The 2x.
Multiplying by the 2x, negative 2x. So we're multiplying that by negative 2x. So let's watch against what going against. It most like against it when it against it. Oh! All right. And that's equal to, remember this is a fraction, so this is same as 7 over that over 1, don't? Okay? So that'll be equal to 1 minus x, right? Follow that?
You didn't work out what's in the bracket just now?
No, man, I never got the bracket yet. Negative 2 times 7 1, negative 14.
Minus 2.
And negative 2 times negative 2x is what? Positive 4. Okay, plus positive 4 what? X?
Yeah.
Okay. And that equal to what? 1 minus x, don't? Now, when we solve this with the value of x, what value of x should we get according to the graph? What should be the simultaneous x solution? When we plot the graph, where did the graph?
1.
Is it 1? Is x is 1 or x is 3?
Is x in 1 or what, sir?
Was the x 1 or was the x 3? 3. Didn't you write down the solutions? See the graph there, Trisha? See the graph there?
Oh, yeah.
Then the x value was 3, right? 3.
Right.
And the y value was 1, right?
Mm-hmm.
Okay, let's get back to the graph. All right, now, so we're saying, Trisha, with this solution, when we finish solve for x, we must get 3 as the answer. All right, wrong, don't?
Right, yes.
All right, so let's solve for 3. To solve the equation, we need all of the x values on one side. Let's say go.
Mm-hmm.
So
Right.
they could bring over the negative x over here, so right?
Mm-hmm.
When the negative x comes on the other side, what does it become?
Positive x.
So we can write, this, I'm bringing this all up here. So here, see here, I bring up here, so
Mm-hmm.
plus space. So it becomes 4x plus x
Plus x.
plus x equal, we don't want a negative 14 over there, so we have 1, and what can negative 14 go on the other side become what?
Positive.
Positive 14. Okay? Following?
Mm-hmm.
Okay. Now, sure, something right as full foolish, man. All right, so we can simplify. 4x plus x is what?
5. 5x.
5x. And 14 plus 1 is what?
15.
Okay, so 5x equal to 15, right?
Divide
And we divide the 15 by how much?
5.
So x equal 15 divided by 5, which equal to what?
3. 5 and 5. 1, 3. Can I break it down?
Mm-hmm.
3.
3. So we get the answer 3?
Yes, sir.
Okay, but we're not done yet, because we only have the x value, right? And we're
So we
also
need the
going
y
to
value now.
So what do you think we're going to do with the x value to find the y value?
Yeah.
Put the x in any
We're going to put
of
that
the two
instead of that, we're going to work it with the 3 now. We're going to work the equation using the 3.
Origin 3. Any of the two equations, just substitute the x value of 3 into it, any of them, and it should give it the same y. Okay? So let's try. Let's try this one over here, so it looks easier. So y equal 7. You can work it out now. Work it out. Y equals 7 minus 2 times 3. And when we do it, we must get 1. Are we wrong?
Equal
7 minus, it's the internet and the internet problem. Why is it out like that? 7 minus 2 times 3. And you need a guess, you need a second guess to know what's the answer for this? What is y equal to?
um
7 minus 6 is what?
7 minus 2.
No, 6. 2 times 3, Trisha. Remember, you're substituting the x value in the equation.
So let me just write to do what I get.
Remember, it's 2x is 3, right?
Yeah.
Remember, I was saying, Trisha, that if the two equations.
Yes, sir. No, because what happened? Let me do. What I normally when I put it in the calculator, so because I was at 2, so she just said 6, me I tell her say no at 2.
Oh.
Because when I just put the 7 minus 2 times the 3, would I get 1?
Okay.
But I was thinking you were making a mistake for 2.
Okay, gotcha.
Yeah.
All right, so let me wrap up this now and show you, and we'll go again. We say, when we set the equations, when we solve, make y the subject, we could have made x the subject of the equation, but I chose to make y, right? But by making y the subjects of both equations, we were able to set both equations equal to each other, right? Because we're saying that when we solve them simultaneously, both equations will have the same value of x and the same value of y, okay? So we basically are saying that y equal y, okay? Over here, so we solve the equation for x, and we say that the simultaneous x solution is x is equal to 3, okay?
Yes,
And again,
sir.
we're saying that once the two equations have the same x simultaneous solution, then they will also have the same y simultaneous solution, okay? Therefore, if you substitute the value of x into any of the two equations, you will end up getting the value to be what? Drum roll. Y.
To be 1.
1. Okay?
Y equal 1.
If you want to try the next
Yeah.
equation, if you use the next equation, you get 1 minus 3, don't?
Mm-hmm.
And 1 minus 3 is what?
-2.
And -2 divided by -2 is what?
Where was that now?
-2 divided by 2 is what?
1.
1. So -2 divided by -2 is? 1.
1.
1. Negative divided by negative is a positive. Okay?
Mm-hmm.
So it doesn't matter which equation you use, you get the same answer. Capish?
Okay.
Cool?
You know which way me do it now, sir?
You use elimination, but I want you to understand what you're doing.
What's the elimination? The one where you go across and say you call that one and the next one.
Next one, 1 and 1. No, you subtract. I'll erase this one. You write this already? You have this copied already, so I can remove it.
Yes.
All right, so what you did was most likely this. You had 2x plus y equals 7. But like it or not, when you're finished, you still have to do part of the next method. So that is why that's make students use one method alone and done. And when you get quadratic equation to solve simultaneously, you can only use substitution. So, all right. So what you did with this was you equated them. You multiply this by 2, no? Or by -2. You say do.
Mm-hmm.
You multiply this equation.
No, I do the top by the bottom and the bottom by the top.
Top by the bottom and the bottom. What do you mean? No understand.
Like, I'm gonna explain this. No. So this would be 1 up here, and then the you see my mouse?
No, I can't see nothing you're showing me. Not unless I give you control of the screen. You can write on the screen and just,
Sir.
just write.
Continue.
Huh? Anyway, you would have multiplied this equation, the whole of this equation by 2, by -2.
Right, to get them.
So we can subtract one from the other. So it'll get this equation will become -2x plus 4 plus 4y, okay?
Mm-hmm.
Equal -2. You see me?
Mm-hmm.
Then now, when I subtract this, add the two equations together. So this is now this equation now becomes the bottom part. Okay?
Mm-hmm.
So when I add the two equations together, I get 2x plus -2 gives 0x, right? Hello?
Yeah, I'm hearing you.
And y plus 4y give more 5y.
Y plus.
So I go on here, so?
Uh-huh.
And then 7 plus -2, that give more 5.
Yeah.
And then now solve for y. Y would I equal to 5 divided by 5? Equal 1, right?
Mm-hmm.
Mm-hmm. But what I'm saying to students is that elimination method does not show you the concept. Follow me?
Okay. Okay.
It's a procedural it's a procedure. It's not a concept.
Oh.
You wouldn't be able to see where, oh, you really are trying to find one value of x equal to the two of them equal to each other, blah, blah, blah. You follow me?
Mm-hmm.
It doesn't allow for the concept. It's an easier method.
Okay.
But once you understand substitution, elimination is not for you.
Okay.
When you're done now, you just make x a subject of any of these equations.
Mm-hmm.
And then substitute y into it and get the value of x. Okay?
Yeah.
Right. However, I wish for you to work with substitution. Why? when you get quadratic equations to do, you're going to have issues with elimination. So you must learn substitution. Cool?
Okay.
All right. Let me just once I terminate this session and join again, then we won't need to do it again because we're